Well, hello there. Tonight, I want to talk about derivatives of inverse functions. Now, we've talked about inverse trig functions, but we haven't really talked about the relationship between the derivative of a function and its inverse. Is there one? Well, you might find some formulas in your textbooks, g of y naught and f of x naught and f prime of x naught, g prime of y naught, and 1 over this and 1 over that. Fine, you can memorize those, but I'd like to show you tonight how I think about the derivatives of inverse functions in their relationship. Before we do that, let's remember a few things from our high school algebra class about f and f inverse. There's really two big graphical ideas. The algebraic idea is that f of f inverse equals f inverse of f, and they're both equal to x, right? But how do they behave graphically? Let's see. We know that they are both reflections over this line. In other words, this is a mirror. So if you have a function here that we'll call f, its reflection, so let's see, that might look something like that, right? Does that look about like a reflection? That would be f inverse. And more important than that, if you have a point on f, say, oh, I don't know, a comma b, there is a corresponding point on f inverse, right? Say b comma a. Really? Yeah. So if, for example, the point 2 comma 7 were on f, then the point 7 comma 2 would be on f inverse. And in calculus, we want to know, hey, if the function and its inverse have this relationship, well, what about the slopes of the tangent lines? Do they have a relationship? Funny you should ask. Now, like I said, you can memorize the formulas, but let me show you what I do every time I encounter this problem. And it takes about 30 seconds, and it doesn't require any memorization other than your basic derivative rules. But you don't have to memorize anything special. It's just that whenever you encounter a problem that has a function and its inverse and something about the derivative, you say, hey, I'm going to do this. Watch. I pick a function, usually one that's friendly, y equals x squared. And I pick a point, 3 comma 9, for example. Now, I know the inverse of x squared. That's y equals the square root of x. And the square root of 9 is 3. So now the question becomes, what's the relationship between the two tangent line slopes here? Is there one? Let's find out. Okay. So I know that y equals x squared has a derivative of 2x. And I know that y prime in 3 is 6. I know that y equals root x has a derivative of 1/2 x negative 1/2. So think about what that is at 9. It's going to be 1/2 9 to the negative 1/2. Come on, algebra pants. They still fit. Kind of like skinny jeans, but they still fit. Do 9 to the negative 1/2. That's 1 over the square root of 9. 1/3. So 1/2 times 1/3. So if I do y prime of 9, that's 1/6. Oh, that's the relationship. And now I can answer any question. If you're taking the old AP calculus exam, there's probably 1 or 2 in the multiple choice that are dealing with this. And you know what? They're very straightforward. But I'm telling you tonight, I've been doing this for a long time. I don't even have that stupid formula memorized. Is it f prime of x naught is 1 over g prime of y naught? Something like that. Whatever. I just draw this little picture here. And it helps me understand that this tangent line slope and this tangent line slope, it's not really a tangent line, this tangent line slope and that, they're reciprocals. And they deal with 3, 9, 9, 3. So here and here. And that's how I approach the derivatives of a function and its inverse. Just draw the little picture, understand the relationship between a comma b and b comma a, and calculate your slopes. And if it's, in this case, it's true for x squared and root x, it's actually going to be true for all inverse functions. Now, there is a proof of this, and I'm happy to show you that sometime. But really, just crank this out. And you don't have to choose x squared and n square root. You could do x cubed and cube root. You could do 2x and 1/2 x. I don't know. But here's the deal. Reciprocals. And that, my friends, is a short lesson on how to think about a function, its inverse, and their derivatives. Good luck.